Okay, lots of requests for number 16. I know, I knew that this would be giving some headaches as you guys are working through this. I know you guys sometimes struggle on the proofs, right? So let's talk about some general things you need to think about with the parallelogram and proofs, right? We want to think about, once we're given something as a parallelogram, we want to think about all the different things that are available to us. So when you're reviewing for the test, it's helpful to go back through your notes. Try to see how many you could name without looking back at your notes, and maybe make a special star by the ones you forget often, so you keep coming back to it. Okay, so we're given it's a parallelogram. Lots of things we know, right? There's about 4 or 5 different properties that we've been using, and there's 4 or 5 different ways we've been proving something is a parallelogram, so really important to go through those things. I'm not going to speak about them all again. Now in this one, we're given AF, let me circle that in green, is congruent to CG, okay? Which, those two segments that are given congruent, there's nothing significant about them, except for the fact that they share, look at what I drew, since I drew them in different colors, you can see they shared that middle portion. This to me is just screaming. It's like somebody is standing, somebody is walking in jug and just screaming, "Hey, guys, stop sinning!" Right? Well, it's obvious. Like, it's obvious there's something you need to stop doing to keep from walking in jug every day, right? Well, same thing here. Like, this problem is just screaming something's going to happen to get rid of GF, and maybe we need to be looking at AG and CF, right? Maybe AG and CF are important. And when I look at that, I think, wow, well, there's 2 triangles there, right? There's 2 triangles that are involved with those segments that look like they might be congruent. Okay, so before I even continue the problem, I'm thinking this is where it may be going, right? Then I've got HB is given to be congruent. Now this, again, HB is congruent to ED. Those segments don't look very significant, right? They're just 2 segments. They're not involved in anything, right? But again, they're part of something. They're part of a greater cause here, right? They're part of segments that I know are congruent because they're opposite sides of a parallelogram. So if I was reviewing through my different things about what that given information was about, I'm already thinking opposite sides are congruent, opposite sides are parallel, et cetera, et cetera. And now I'm given part of it, right, are congruent. And I'm looking at those 2 triangles I highlighted in my head there. And this has been changed, right? This has been changed. I believe we're trying to prove GH congruent to FE. Okay? Trying to prove GH congruent to FE. Okay? Now, trying to prove GH. Oh, and GH and FE, but lo and behold, those are in my triangles. Okay. So I think at some point we're going to try to prove those triangles congruent. Maybe we can't get GH and FE right now are not in anything else significant about the parallelogram. They're not in anything else that was helpful, except they're in the triangles that we've thought that might be significant in this problem. So let's go and let's kind of erase what we're looking at here. Let's try to see if what we're doing leads to what we're thinking we might need to do. So can we somehow get these triangles congruent? I'm going to highlight them. Can I get those triangles congruent? Okay. Now, again, if I had given the information, so first thing is you would basically just write out what is the given information, right? Okay. And that would be that it's a parallelogram, you have this and this, right? Just write that all down. I'm not going to waste my time and talk about it. But that initial thing that we talked about was that AF and CG share that little GF. So you can imagine subtracting out GF, but in order to subtract it out, right, we subtract it out using subtraction property of equality. We need an equation that has GF in it. Otherwise, we can't subtract it out. And it would be helpful if we had an equation with GF in it on both sides, right? And I can see how I can get that. I can get AF, right? Oh, sorry, AG plus GF in an equation, right? AG plus GF is equal to that segment AF by the segment addition postulate. And the same thing happens up there. CG, and I'm just going to call it GF again. CF, CF plus GF also, or it equals CG. Okay. Now look, the point there is that we kind of knew what was happening already. Both of those are by the segment addition postulate. But because we're given that they're equal, they're congruent, right? Now I can say they're equal in length, right? So third thing I want to say is, and I can go ahead and just, I've allowed you to go ahead and say, because they're congruent, they're equal, but you gotta give a reason here. So AG plus GF is equal to CF plus GF. That's by transitive property. And I would also say transitive property and property of congruency, right? Sorry, of equality and definition of congruency. Because from the given, you were given AF congruent to CG. Okay? Now, again, the reason why I'd like to do that is to be able to subtract out GF. Now we can subtract out GF using subtraction property of equality, right? Subtract GF on both sides, subtract GF on both sides, and you get AG equal to CF. Once you get AG equal to CF, okay, that is by that step is by the subtraction. I don't know why I'm so thick here. Subtraction property of equality. Okay. Let me erase that. It looks too big to me. I subtracted GF. I subtracted GF on both sides. I got AG is equal to CF. Okay. AG now is equal to CF. Okay. Want to get these two triangles congruent, right? Now we got to start pulling in our properties of parallelogram. Okay, let me label these angles in here, angle 1 and angle 2. Okay. Now, what do we know about angle 1 and angle 2? Well, angle 1 and angle 2 are alternate interior. They're angles I want congruent in those two little triangles, but they're alternate interior in the parallel lines based on the parallelogram. But I haven't stated that those lines are parallel yet, right? So I need to state lines DC and AB are parallel. DC is parallel to AB by definition of, this is going to be long, of parallelogram, right? So then angle 1 congruent to angle 2, alternate interior angles congruent from parallel line theorem. Okay, I got to continue on another video. Thank you.